this particular site is one of our research projects we've been running for a while. We actually started with 4 years ago. This is the 4th year of this particular site. And just in terms of generalities, maybe the first question we'll just talk about is why would we do a variable rate fertilizer project? Well, when we look in Alberta, we've got about 25 to 26 million acres of annual cropland, and probably 30 to 40% of our land across Alberta has topography like this. It's actually fairly variable, which means the soils are different in the upper versus mid versus low slope positions. And as a result, crops will respond differently to different types of fertilizers. And so one of the things we wanted to look at was, would it actually be feasible to actually put on different levels or different rates of fertilizers on different slope positions? And certainly there's about 6 different equipment manufacturers that, for example, John Deere has equipment that, seeding equipment that you can use to variable rate apply your fertilizer. And there's about another 5 different equipment operators or companies that manufacture seeding equipment to have that ability. And also there's a number of agronomy groups that are making recommendations to farmers now to variable rate apply fertilizer. And different companies have different philosophies. Some use yield maps, some use near infrared imagery satellite imagery to look at soil. They're trying to determine the different soil areas in the field and to make these prescription fertilizer maps. So there's a lot of different things being done, and that's one of the things we wanted to actually look at is what is the different levels of fertilizer response, first of all. And that was part of this study, was to look at if we apply, and in this particular case we have a number of different fertilizer treatments, 13 as a matter of fact, and then they're actually applied across the length of this field for a half a mile. And then we have different benchmark locations where we do a lot of soil sampling to characterize the soils physically and chemically, and then try to decide what are the major factors that are really controlling yield and fertilizer response. And so we have this particular site. Unfortunately, this site actually got hailed out just over a week and a half ago. It's only been hailed out once. In my home, I've had hail 5 times already this year. So this is a light hail damage compared to some. We actually have an irrigated site not too far from here, and we have so basically we have one irrigated site in the dark brown soil zone, this site in the dark brown soil zone, another in the thin black south of McGrath, another one in Claresholm, and we have one up in the black soil zone at Vegreville. So we're using these 5 sites to develop try to develop a good feel for what is the level of fertilizer response, different slope positions on different soil types over a period of years. This is kind of the last year for this project, and so not only are we doing these strips here to look at fertilizer response, but we also wanted to take what we learned and then apply it on a field basis too. So in this field, we have 3 different rates of fertilizer in different soil areas. And so our goal was to really develop a much better feel for fertilizer response at different slope locations, and then how could we actually differentiate where should we put on those different rates or types of fertilizers. And that was really kind of the goal of this particular project.
So one of our underlying assumptions was that there are soil factors that would affect your fertility decisions and your variable rate application. And so this is an atypical, anybody who's been used to doing small plot work, this would not be the type of site that you would want to see, but we have chosen a landform type approach because of the influence that slope and water has on soil development, and based on soil development, we're thinking that there would be differences in fertility responses. As you look across this, some of the highlights, we have about a 2% swing in organic matter from what you see in the top of the hills to what you would see at the lower slope position. So top of the hills are probably running somewhere around 3.2% organic matter. The lower slope positions are probably running about 5.3, 5.4% organic matter. One of the other things that swings quite dramatically, pH would also follow that same pattern. Hilltops would have a higher pH, probably running about 7.5. Lower slope positions are probably running right around 6. Phosphate on the hilltops is quite low, quite high in the low slope position. So there are some soil properties that change quite dramatically as you move from the top of the hill down to the lower slope position. As Ross mentioned, the first year we had 2010 was the first year we were in the field. We had flax on this land. 2011 was canola. 2012 was durum wheat, and this year we're back to durum wheat. But based on our results in 2010, 11, and 12, we came up with a recommendation for the rest of the field based on slope position. So that's, and not everybody has this luxury of running essentially yield response curves using a full range of nitrogen treatments. We've included with and without phosphate. We've included with and without potassium. We've included with and without some micronutrients. Not everybody has that luxury of doing that for a number of years to try to figure out what you might do in the rest of the field, but that has been our approach here on this field. So we've got 0 nitrogen, 30, 60, 90, 100, and 20, 150. So a full rate range. For the most part, our mid-slope and upper slopes are probably fairly similar in their response, the shape of the curve, with very good response up to about that 100 unit of nitrogen. Our low slope position kind of flipped a little bit, where it had been a couple of years of responding all the way up to our top rate, and a year where our lowest rate was essentially flat from our lowest rate across. So it did make for some challenges of trying to figure out what we did. But on the rest of the field, we ended up going with 60 units of N on the low slope and 90 units of N with a low rate of phosphate on the mid slope and 90 units of N with a high rate of phosphate on the upper slope. We'll have to see what at the end of the season whether we guessed right or not. Not guessed right. Whether we applied the science right or not.
So do you want to talk about where you took the course first? Which ones you're taking from where?
Actually, the low is just down kind of by that yellow flag just where near the cattails. So that's the low. The mid was about halfway up just on the edge of the slope. And then the upper was up in the upper slope position. So basically, yeah.
So this lower, mid, upper?
Correct.
That's the way it should be, yeah. So when you look at these, you can see the rate right off the bat in terms of the knoll. We can see about maybe 2 to 3 inches of topsoil. For the mid slope, we probably have about 6 inches of topsoil, and then the low, that's kind of a puzzle, because odds are this material here is probably fairly recently flown downslope, and so this would have been the top of the horizon, and then there's been some material flow over and deposit over top of it during an erosion event. But then you can see that it is quite a bit higher in organic matter, quite a bit darker down to here. So when we've been doing our work, usually we try to pick, in this particular case, we actually have 16 different benchmarks. So we have our 13 different fertilizer treatments. Each treatment is 2 meters wide, and then we drive the entire length of the field, put it on that rate of fertilizer, then come back and then put on the next rate. Then we have these 13 different rates of fertilizer, and then we have 16 different benchmark locations where we actually have soil sampled in detail. So we'll actually take 6 soil cores in this one strip and analyze them in detail. We look at soil organic matter, soil pH, soil texture, all the way down to 100 centimeters. And we look at nitrogen, phosphorus, potassium, sulfur, and then we look at a range of micronutrient fertilizer or micronutrient levels in the soil as well. And so then with these fertilizer treatments, then we can actually see what's responding and what is not responding. And we've been doing this now for 4 years. It's actually giving us some very good information. And to be honest, Doon actually mentioned that the soil pH went down to 6. And in fact, the lowest pH we're actually finding in low slope position was about 5.4. And so the upper slope would be about 7.8. So that's huge variation. And so right off the bat, organic matter is varying tremendously. Doon mentioned that in the upper slope, we'd be as low as 3. In fact, sometimes we're even less than that. But typically, in the lower slope position, we're up at 5 to 5.5, which is actually a bit of a surprise. So we're actually finding maybe a bit more variability in some of our physical and chemical factors than what I really thought. very clearly we knew that phosphorus would be low in the hilltops, and they are. They're very low in the upper slope and mid-slope positions, usually not bad in the lower slope positions. And last year, in this field, you could actually stand on the hilltop and look at the phosphorus response. It was very dramatic in the upper slope and in the mid-slope position, but almost petered out, so you could barely see it in the lower slope position. 2 years ago, we had canola in this field, and in the upper slope positions, even though we have sea horizon material, typically the sea horizon is at about 6 inches, and so we have calcium sulfates, you know, in fairly good abundance down here. Initially, you could see quite dramatic differences initially in the vegetative growth of canola with a lack of sulfur on just on the hilltops, and eventually they kind of grew out of it. But so nitrogen response was excellent across all 3 slope positions. Phosphorus response was very good in the upper and generally in the mid-slope positions, but then petered out in the lower slope position. No response to potassium. We have potassium, though, is actually quite variable. In the upper slope positions, it'll be down around 400 pounds per acre, but then in the upper slope positions, it'll be as high as 1,000 pounds per acre. So quite dramatic variation, but in all cases, our potassium levels are well above the critical limits. We don't have to worry about potassium. And then sulfur, it is generally limiting, especially with canola. We didn't actually see response last year in the durum wheat, or in the first year with canola. Sorry, with the mustard. Sorry, with the flax. But with the canola, we did. So even the responses we see from year to year will be different depending on the crop that we're actually growing. So there's a lot of different things to kind of consider. And we also know that there's lots of recommendations for micronutrients. That's where a lot of the micronutrient fertilizer salesmen make their most money, is selling micronutrients. The micronutrient values are marked up much higher than other fertilizers. In my opinion, micronutrient fertilizers are grossly over-recommended, but a lot of farmers are using them. And the reality is that most of the time we don't see response. In terms of copper, the copper is always good in most of our fields across southern Alberta. But it's not uncommon to find, especially in upper slope positions, where zinc levels are getting down to maybe a 0.5 part per million. But even at a 0.5 part per million, we're not seeing response. And typically, we wouldn't really expect to see response until we're well below that 0.5 part per million of zinc level. So that, in a bit of a nutshell, is kind of what we're seeing, and really what our goal is then is to look at all the physical and the chemical factors. Doing soil, really looking at multivariate analysis to really look at which factors are the major factors controlling response. And so it's actually quite exciting to be involved in this project, and to really kind of draw things together in this final year will be quite nice. But like I said, I really look at this as a real nice first step to learning more about variable rate fertilizer application. I think we'll see a lot more of it down the road. But one of the things we'll have to ask ourselves, where is it worth it, and when is it not worth it? It's certainly in fields like this that are kind of quite variable. It would actually pay to put on probably a higher rate of nitrogen with phosphorus and sulfur on hilltops. But on lower slope positions, because we have higher organic matter levels, higher mineralization potential, we can actually put on less fertilizer. But if you look at the yield maps, some people say, well, you want to put on more fertilizer where the yields are higher and less fertilizer on when the yields are lower. Well, the yields are always going to be lower on the hilltops. If you put on a little bit more fertilizer, you can bump up the yield and get a better value for that fertilizer.
I don't know if you said it already, you have 2 meter wide strips. Are you using the same strips for the same treatment every year, or do you go to a different spot?
Oh, actually, we go to a different, basically we've just been shifting, so we're not staying on the same spot. We kind of wanted to have our original one where we stay the same, and then have new ones each year, but we moved each year. And because even just with this strip, 13 treatments wide, half a mile long, like 800 meters long, that's 6 acres. So but the farmers have been extremely cooperative. Actually, all the farmers have been extremely cooperative, but we have been moving each year, so you can look at a fresh start each year. So
when you did your baseline study, did you find, you noticed that there were differences in organic matter content, pH, nitrate? Can you recall, put you on the spot, but can you recall what the inherent difference of nitrogen might have been from?
To be honest, I can. Because, as a matter of fact, we do that detailed analysis every year. Okay. Because our benchmarks shift every year. We can see how the topography is. But it's interesting with nitrate and nitrogen. I'm going to go by memory, but in the top 24 inches, our range was about 15 pounds to about 27 pounds. from the lowest to the highest. That's all 16 sites. So our nitrate nitrogen was relatively low across all benchmark locations. So nitrate nitrogen was low. Phosphorus levels were highly variable, anywhere from like about 5 or 6 pounds per acre up to about over 90 pounds. Potassium, I mentioned already, ranged from 400 to over 1,000. And then sulfur varied anywhere from detection limit, which was 5 pounds, up to about 30 pounds. So, but potassium was by far the most variable in terms of the actual number difference, but we don't have to worry about potassium. But nitrogen is really the one where most of the people are making most of their claims in terms of different rates of nitrogen, and that's actually where we found the least variability was on nitrogen. Nitrogen always gets sucked down. If you have a good year with good moisture, you always get sucked down, so it's relatively low. So then what the difference though is, if you have a soil like this with a very thin A horizon and lower organic matter versus the lower slope position, a much thicker A horizon, much higher organic matter, much higher mineralization potential, so our response to nitrogen fertilizer is lower in the lower slope positions than they are in the upper slope. But then people are saying with our yield maps, that's where we're getting our best yields, that's where we should be putting most of our fertilizer. And it's exactly opposite to probably what we should be doing.
This farmer, again, no-till, long-term, I think he's had this field around 15 years. He seeds with a disc-type seeder. He's managing for kind of a duff layer. Doesn't show up so well right now, but he actually uses a stripper header, just takes the heads off. All the straw stays, it's long straw, tends to build up a nice residue layer on the soil surface, and excellent moisture management. Lots of earthworms at this site, good infiltration and rainfall, all that good stuff associated with our conservation tillage system. So.
And it's for that reason he's really been able to kind of build the organic matter levels in his upper slope positions. There's lots of room for improvement, but he's been doing an excellent job.
For any of you that are familiar with small plot research, this is not your typical small plot research site. Small plots, we usually try to pick as uniform piece of land as possible, whereas here we wanted something that was as diverse as possible. Were any of you at the Soils Workshop in February? A few? I presented some of this information at that site. Ross mentioned that different companies take different approaches. We have assumed that landform affects yield because of moisture, and most of the time moisture is very limiting here, and it really affects the way the soils have developed here, or in some cases some of the anthropological effects and how they've eroded. But we do have that roughly 2% swing in organic matter from the tops of the hills to the low slopes. We also have very consistent phosphate effects, where the phosphate on the upper slopes is low compared to mid-slope and lower slope, and that's why we do have treatments with and without phosphate, and we have had a consistent and almost significant effect to phosphate here. Also zinc, it tends to be low on the upper slope position, and we've had a consistent but not quite significant response to zinc fertilizer on our cereals here. And for anybody that knows Ross, for him to almost recommend zinc on cereals would be a real stretch for him, but we are almost seeing that here. And it's something that you would not normally see if you were only basing things on nice, level, uniform land. That we do see dramatic shifts in some of those soil properties.
This field is never irrigated, right?
This field is not irrigated. But we have had, 2010 was our first year in the field. We had flax. 2011 we had canola. 2012 we had durum wheat. And this year we're back to durum wheat. For the first 3 years of the project, we've had extremely good yield because we've had probably exceptional growing seasons. This year we were almost hoping for getting close to average, just to see what we would get for responses. We've had very strong nitrogen responses here. We go up to 150. I don't trust my memory. The first year I think we went up to 90 units of N, but then we realized that we were not plateauing yet on any of our slope positions. And so then we had to So for subsequent years, we had to increase our rates. And if you did the yield response curve, very similar at the upper slope and mid slope positions. So very strong response up to roughly that 100 units of N. Our low slope actually, for 2 of the 3 years, it never plateaued. It was a linear response across our entire N rate. Then last year, it was almost flat with no response to nitrogen whatsoever and very good yield. So that really confuses matters when you try to make a recommendation that 2 out of 3 years, based on 2 out of 3 years, you'd be recommending fertility on those low spots, and 1 year, your recommendation would be 0. So do you put 120 on it, or do you put 0? It's almost the same. So we actually went a little bit conservative on our low slope positions on the recommendation for the entire field. We went with 60 units of N, and so we basically went 60 as our low slope position on the field with a low rate of phosphate. On our mid slope, we went to a higher rate of N with a slightly more phosphate, and on the upper slope position, the same N rate as mid slope, but with even more phosphate. Any questions about what we did or why we did it? Here we're standing by a mid-slope position, and you would think that would be easy to figure out what a mid-slope is, what an upper slope is, and what a low slope is, but sometimes we had to do this by committee. And you get to one of these, and yeah, here it might be mid-slope, but there it's almost, on that side of the plot, it's almost getting to upper slope. So sometimes it really did take a kind of a vote of 4 people to try to figure out where we were in the landform. And then David Speece, who's in the other group, was very involved in helping us develop the landform maps. And in your binder there is a landform map for this site. And sometimes what we called a benchmark position didn't quite jive with what the computer spit out, but most of the time it was pretty consistent. I grew up in central Alberta, and my perception of southern Alberta was you're going to have high pH soils, and you assume that everything down here is going to be in that 7.5 range. Here, yeah, the upper slope is in that 7.5 range, but those low slope positions are down closer to 6 and sometimes just below 6. There's a lot of peas grown in southern Alberta, and all those peas get IMI-type herbicides, which persist in low pH conditions. So this project was really eye-opening to me from that perspective, that there's a whack of land that could have low pH, where we could have all kinds of herbicide residue issues that nobody is really looking for or looking at. So there's, since I wasn't from southern Alberta, this project has really kind of shaken my stereotypes or perceptions of what the land is like down here, that it's not just flat and perfectly uniform, that we have all kinds of variability here as well.
If you had really dry conditions, you had 4 good years of good moisture, if you had really dry conditions, do you think that would have any impact on the results and the way that the crops responded to fertilizer?
It should have. And like I said, we've had, the upper slope positions have had very strong responses to even what I would call aggressive rates of fertility. And that's why I was hoping that this year would have been closer to dry, not drought, but closer to average, so that might have tempered our interpretations of the results. Because right now we have had very strong responses to fertility. When you look at the landform, you would have assumed that moisture would have been more limiting than that.
You're not going to be able to harvest anything off of these plots this year?
We will still harvest. And I was here last Wednesday, and the site looked a lot worse than it does now. So the results are going to be impacted, but it's still going to be harvestable. I was thinking it might just go downhill from then because there were so many broken stems. But I think it's still looking harvestable.